This is section 6.2b, the law of cosines. Today we're going to look at some word problems that help us to understand the law of cosines by applying it. The first word problem is this one. Two ships leave a port at 9 a.m. One travels at a bearing of north 53 degrees west at 12 knots, and the other travels at a bearing of south 67 degrees west at 16 knots. At noon, how far apart are the two ships? Alright, just a quick reminder, a knot is a nautical mile per hour. So of course if you multiply hours by knots, you get nautical miles. A knot is just a nautical mile per hour. And you might recall that that was explained in chapter 4 when we were at the end of chapter 4 and we were talking about bearings. Alright, so the first thing you want to do is pause the video, try to sketch this problem accurately, and then resume when you have a sketch. Alright, so your sketch should look like this. You know that you can always draw a dotted line to indicate a north-south line, and that will help you to visualize the two bearings. So looking over here at this bearing 53 degrees, so you know that you the angle has to touch the north-south line, and the N or the S is always mentioned first, and after that the W or E. So this is north 53 degrees west, and this angle down here is south 67 degrees west. Now another part of the sketch is labeling the sides. We know that the ships have traveled for 3 hours, so 3 times 12 is 36, and for the other ship 3 times 16 is 48. So as you can see, we now have a triangle we can sketch using the fact, of course, that looking at that dotted line, the angles have to add up to 180 along a straight line. We can figure out the blue angle, 60 degrees, and thus we have a triangle that is SAS, side angle side. Okay, that's the first part, just sketching accurately. Now you want to pause the video again and figure out what side C is, and then resume when you have an answer. So we're going to set up the law of cosines. We have our angle C, and we're trying to find our side C. We know A and B, and therefore we can just plug those in and calculate, and we get 1872 as the square of C, and then of course C by itself is 43.3 nautical miles. 43.3 nautical miles. The next example, in a softball game, a batter hits the ball 240 feet to the center fielder, who then throws to third base. If the distance between bases is 60 feet, how far was the throw to third base? Alright, so you can assume, of course, that the batter is hitting the ball directly to the center fielder, and that it makes a straight line right to the center fielder, intersecting second base. So you can visualize it that way. Now remember that half the battle of these kinds of problems is getting the sketch right. So we're going to do 2 checkpoints again with this word problem. First I want you to pause and try to sketch accurately, and then when you've done that, resume the video. Alright, so this is what your sketch should look like. You've got that baseball diamond. The central dotted line, this longer one here, that central dotted line, of course, represents the hit, which goes over second base directly to the center fielder. And then that next dotted line on the left represents the throw from center field to third base. Now, we do also have other information. We know that the hit from home plate to center field goes 240 feet. We also know that the space between bases is 60 feet. And thus we can make a nice triangle that is SAS. SAS, side angle side. Okay, now you need to pause the video again and try to figure out what side C is, and then resume when you have an answer. So using the law of cosines again, I'm going to try to find out what side C is, and we plug in our information. We've got 60 squared plus 240 squared minus 2 times 60 times 240 times the cosine of 45 degrees. And I'm kind of assuming that you know this. Maybe I shouldn't have. You know, the baseball diamond is a square. And since it's a square, we have 90-degree angles on all sides. And so when you bisect the 90, you get 45 degrees. Now, I kind of assumed that in the sketch, but if anyone needed that extra clarification, then that's for you. All right, so plugging all that in, we can figure out that our side C is 202.8 feet. And therefore, the throw from center field to third base was 202.8 feet. Last word problem. When a man was knighted in early medieval France, he could ride from sunup to sundown to trace out his new land. He could make a square or a circle or a trapezoid or any shape he wanted. If a new knight rides 40 miles east, 30 miles northeast, then 56 miles back to where he started, what is the area of his land? Okay, so once again, half the battle is drawing the right sketch. You may see that northeast and wonder, well, what angle? For this problem, it really doesn't matter because you're given all three sides of the triangle, and therefore, you know, for your sketch, you don't have to worry about what angles are actually being made. All right, so pause the video, do your sketch, and then resume when you have that done. Okay, so this is what your sketch should look like. You label the three sides, and you label the starting point. You can call that angle A because you don't know what its measure is yet. And your three sides are 40, 30, and 56. Starting at A, the knight goes 40 miles east, and that's why this goes straight east. Then he goes 30 miles northeast. Again, you don't need to know the exact amount of northeast, so just something general is fine. And then he goes back to where he started, 56 miles. So this is our SSS triangle, side, side, side triangle. All right, so you've got the sketch now. Pause the video, try to do the rest on your own. Remember that you're trying to figure out the area. And then resume when you have an answer. And just a quick reminder, the area of any triangle, no matter what its shape is, the formula for the area is 1/2 base times height. Okay, so pause the video and then resume when you have your area. We set up our law of cosines. A squared equals b squared plus c squared minus 2bc cosine A. So now we can just fill in the information that we know. We know the three sides. So we, of course, put those in. And we're solving for the angle that's opposite side 30. So we find out that angle A is 31.1018950348 degrees. Now, as I've said before, it's a good idea not to round until the end. So that's why we're keeping those decimal places for now. Now, the reason for solving for angle A is because it's convenient for finding the height of this triangle. Recall that the problem is asking us to find the area of this triangle, not just to solve the triangle. And to find area, we need the base and the height, because area of a triangle is 1/2 base times height. Now we have the base, which is 40, but we need the height, and for that we can simply put these dotted lines in here to kind of extend the triangle out, make a right triangle out of it, but that's simply for finding out what h is. Simply for finding out what h is. And we can do that because now that we know what angle A is, we can put h in terms of A by saying sine A equals opposite over hypotenuse, opposite being h, hypotenuse being 56. And since sine A is h over 56, then h is 56 sine A. You just multiply both sides by 56, and you get 56 sine A equals h. All right, so that nicely puts h in terms of A. And so now we can finally get the area. Area equals 1/2 base times height. Height, of course, is 56 sine A. And that equals 1/2 times 40. 40 is the base. Times 56 sine 31.1, etc. degrees. That equals 578.55 square miles. So this newly knighted knight traced out an area of 578.5 square miles in his ride from sunup to sundown. That's actually a pretty good chunk of land. So classwork is page 443, and these are some pretty fun word problems that we'll work on in class.